Morning geometry classes. We're going to take a look at our 11.5 samples, and this is the lesson where we are talking about our solid figures. We're naming them with their correct mathematical name. We're deciding whether they are or are not a polyhedron, and then we're going to use Euler's theorem to verify the number of faces, vertices, and edges that we can count on a polyhedron. So let's start with samples 1 through 4, where we're naming the solid figure with the correct mathematical name, and then we're going to explain why it is or is not a polyhedron. Sample A, so we're looking at the drawing here, and it looks like a dunce cap, which is the shape of a cone. We have a circular base, and opposite the base we come to a single point. So that actually means that this is a circular pyramid, but we call it a cone. It's not a polyhedron because it has curved surfaces. Remember, polyhedrons do not have any curved surfaces. Sample 2. So we have what looks like a trough, and we notice that we have two bases and all the space captured in between those two bases. Those two bases are half circles. So if those are full circles, we would call it a cylinder. So because those circles are half circles, those bases are half circles, we'll call it a half cylinder. And it is also not a polyhedron because it has curved surfaces. Sample 3. Sample 3, we have two triangular bases and all the space captured in between those bases, therefore it's a prism. And because the bases are triangles, we will call it a triangular prism. It is a polyhedron because it is formed or bounded by polygons. Sample 4, on sample 4 we see a hexagon base, and we see line segments rising from all of the vertices of that base up to a single point. So opposite the hexagon we have a single point. That means it's a pyramid. And because the base is a hexagon, we will call it a hexagonal pyramid. It is a polyhedron because it is formed or bounded by polygons. Here's our last sample for today. We are given this figure and we're asked to state and verify the number of faces, vertices, and edges using Euler's theorem. So the faces are the polygons that form this particular polyhedron, and we see two triangular faces and we see three rectangular faces for a total of 5. We count the vertices, which are the corners. So we will count 3 vertices kind of at the front of this figure, and then 3 more vertices at the back. So those vertices lie on the kind of the ends of those triangular faces. So we count 6 vertices, and our edges are the line segments that connect the faces together. We'll count 3 that go around the triangles. We will count 3 edges on each of the triangles, so 3 plus 3 plus 3 is 9, so we have a total of 9 edges. Then we're going to go ahead and plug those numbers into Euler's theorem that predicts that the number of faces plus the number of vertices will equal the number of edges plus 2. So that means we will have 5 plus 6 equal to 9 plus 2, and since 5 plus 6 is 11 and 9 plus 2 is 11, we have verified the correct number of faces, vertices, and edges on this triangular prism. All right, that is the end of the preparation for today's quiz, so time to move on to the quiz, and after that, our new lesson. We'll see you next time.